Hi there once again and welcome to another Expresso mechanic tutorial, and this is the 8th instalment of the Python Bytes series of tutorials. In this one we're going to be looking at making this. Now, a few weeks ago one of my subscribers, who goes by the name of Link, reached out to me and said, look, I'm interested as to whether or not we can animate an object, or the points and polygons of an object, that's a parametric object as opposed to an object that's been made editable. Now, at the time I wasn't sure that that could be done. I knew that the Python generator could be used to make an object editable and that you could then start manipulating the points and polygons that way. But I didn't know whether or not you could actually do it with something that was purely parametric. Well, anyway, Link found some code and sent it over to me recently, and I've adapted it and made this with that particular code. So that's what we're about in this tutorial. So without further ado, let's see if we can make this happen. First thing to do then is to get a cube, and we're going to give it 2 segments in each of its dimensions. That's the first thing to set up. Now, in order to work with the points, we actually need to know which points we're working with. Now, with this being a parametric object, we've got no data on that. So how do we find it? Well, the easiest thing to do is create a copy of it and make the copy editable. We'll move it to one side, go into points, and now we can see the points. So what we'll do is physically select them. So I'll go into my right hand view, grab a hold of my select tool and uncheck visible only, click there, go into the top view, hold down shift and click there, and then go into the front view. Once again, hold down shift and no, don't do that, and just click there. And now I've got all of those points selected. And then if we go into the window menu and select the structure manager, and one thing I want to point out here is that Shift F9 does not work as a shortcut. I've found that doesn't work, but I'm in release 25. I'm not sure whether that's a release 25 thing, but it doesn't work. So I just thought I'd share that with you. Anyway, let's get the structure manager. Okay, so we can see that our points are 0.4, 0.10, 16, 22, 24 and 25. So we've got that data. Moving on from here, I'm just going to put a null in the scene here, and I'm going to add a Python tag. Straight away we get the Python editor up, the expression editor, and we can start looking at what we're doing here. I'm just going to close this structure manager for a minute. Go into our scripting layout, select this once again, and open in editor. I'll also select Python here and just clear that out. We'll remove this piece of code because we don't need it, and then we can start thinking about what we're going to do next, and that will be to define some global variables. That will be the first port of call for us. So I'll start keying these in, and you'll find out what they do as time progresses, so don't worry about them too much at the moment. Talk amongst yourselves while I do this. Global cube, global start time, which you've seen before. And if you haven't guessed already, we are going to be using range mappers. We're going to be using several of those. Okay. So there are global variables. That's all we need for the global variables. There's a few, but they all become apparent as time goes on, as I say. So we'll forget about those for the minute. Now the next thing we need is the first piece of code that Link sent me. Now, well, it is the piece of code that Link sent me, but I've adapted it slightly. Now, what I'm going to say first is cube is equal to doc, and I'm going to say search object brackets cube. So that's going to find this object, this cube here. It will ignore anything else. It'll just look at this cube. We can then say cube, and this is one of the key pieces of code, or key lines of code. Cube is equal to cube dot get cache. Now the cache is the all-important bit because this contains the point data for a parametric object and enables us to work with it. So we've got that in there. Now what we'll say as well is if not cube, print no cache. So in other words, if we don't find a parametric object, if we only had this object here, this will be printed over here and we won't have an object that we can work with. So we can then say else, if I spell it correctly, cube is equal to cube get cache. So this can be thought of, well in fact it is, an error trap. That's how you can describe that. Moving on from here, we need our frame variable that you have seen me do so many times before. So frame is equal to doc get time get frame doc dot get fps open double close. And for anyone who still doesn't know, that gets the time from here. It gets the current frame from the timeline. Okay. The next thing we need to do is add some user data to the Python tag. So we'll go into our user data here and say add user data. The first thing I need is something I'm going to call setup. And this is going to be a Boolean. So just a checkbox. And you'll see what this is for as the tutorial progresses. So again, don't worry about it. Moving on from here, we'll add some more data and we'll call this Spline. And this will be the spline that we're going to use within the range mapper. And for now, I'll also add another group and I'm going to take that out of there and drop my user data into it. And we'll rename this controls, just to make things a little bit nicer. Okay, so we're here. So we've got controls there, and let's have a look, see what I've got in the user data. It's going to manage user data. Oh, I've done that wrong actually. That should not be called controls. That should be called setup, and this should be called controls. That's better. Aha, there we go. That's much better. Right, so in the spline here, I'm going to hold down my command key and put a point, drag that down to 0, 0, so the bottom left corner, and then put another point and drag this up to position 1 and 1 along both axes there. Twirl it open, and we can then work with the tangents, and they basically need to be minus 0.25. And this one also needs to be minus or 0.25, that's fine. So actually what I need to do, I need a bell curve, so I'm going to bring that down there. Got a bit ahead of myself there. I do actually need a bell curve. Bring this one up, so that needs to be at 0.5 on the X and 1 on the Y. And this needs to be minus 0.25. And the other tangent, 0.25. And we've got a bell curve. Let's see what we've got here. 0.25 and minus 0.25. And that's the bell curve setup. That will work nicely for us. Okay, so that's all ready and that's looking good. The next thing we can do then is drag the spline into the editor, and we'll say spline is equal to op. Just move that forward one space, and that's fine. So that's all ready. That's ready for us to use in the range mappers. The next thing we need to do is define two functions. Now, all I'm going to do is define them, but I'm not going to put any code in them at the moment. So it's def, and this one will be called setup. And I'll put pass under there, and then def animate. And again, I'll put pass under that one for now. Moving on from here, we'll initialize the variables that we need to initialize. So we'll say if frame is equal to 0. So when we're at the start of the animation, we need to start defining a few variables, and constants, of course. So points, we're going to say is equal to, and if we just open our structure manager again and select our cube, now this is going to contain the index values of the points that we need to work with. So we're going to say points is equal to, and it will be 4, 10, 16, 22, 24, and 25, giving us all of these. Okay, so that's our points set up. Start time can begin as an empty list, and also we'll put trigger as an empty list. So we've got those two set up there. Now moving on from here, we need to do something slightly different. I'm just going to close the structure manager. What I'm going to do is drag this setup boolean here, or checkbox as it is. We'll drag that into there, and we'll say if op is equal to true, and at this point we're going to set x to an empty list, y to an empty list, z to an empty list, and xf, x or yf I should say, to an empty list, and finally zf to an empty list. And then we can call our setup function. So in other words, we're only going to call the setup function when we're at the beginning of the animation and when this box has been checked. That's the only time we need to do this. So that's what that's for. We can then say else if len start time is less than 1, start time dot append, and it will be frame because we want the current frame in there. Moving on from here, we can then say if len trigger is less than 1, trigger dot append, and we'll just put 1 in there because it doesn't matter what goes in there. And then finally we can just say animate to call the animate function. So at all other times other than at frame 0, we're going to be calling, and in fact what I should do is actually move this back one tabulation so that it's relating to this if statement and not this one. So if we're at 0, we're doing this. At all other times, we're doing this. All that remains for us to do now then is to define our two functions and get those sorted out, and then we can have a go and see if this actually works. Let's just open our structure manager once again so that we can see what we're doing here, because this is useful for illustration. So I'll take away pass from define setup and we'll start putting some code in there. So for I in range len points. So what we're going to be doing is sequencing through these values, these index values here. And the data we're interested in is the X, Y and Z data that's associated with them. That's what we're going to be doing. So we can say, and this is how we're going to get this data, we can say point is equal to cube dot get point, and it will be points brackets I. So this line of code is going to be getting this data, all of these numbers, as vector values. Okay, so they'll be in groups of 3 because they're vectors. We need to convert vectors to reals, so we need to say x dot append, and it will be point dot x. So all we want for the x's are these values. So we'll want 0, we'll want 100, 0, minus 100 and 2 noughts. That's what we're interested in there. And we're going to populate this particular list with this data. Similarly, we're going to say y dot append point dot y, and that will give us the data here. And then you guessed it, we're going to do the same with z. So z dot append point dot z, and that gets us our data for the x, y and z lists, which is the actual initial position data for these points. So we can see that the x, when they're not 0, they're either going to be 100 or they're going to be minus 100. The same applies to the y and of course the z. So these are important because they're going to be the starting points for our range mapper. So our output range is going to begin with 100 and then it's going to move. And what we're going to actually do is move these points, or it'll be the points on this cube, but we're going to move the points from their initial positions here. We're going to move them up 100 units or out 100 units. That's what we're going to be doing. Okay, and because we're using a bell curve, they'll go out by 100 units and then they'll go back to where they started. That's what we're going to be doing. Okay, so that's what this is going to do. So we're starting at 100 here, we'll go up to 200 and then back to 0, or back to 100 I should say, or minus 100 depending on what it is. So that's what we're about here. So this is where things get a little bit more involved. We can then say if x brackets I is equal to 100, we can say x f, and the f is for final, so that's going to be the final position. So we're starting at 100, our final position is going to be 200 or minus 200. So xf, we can say then dot append and it will be brackets 200, and I'm going to put 0.0 in there because it's a floating point. Moving on from here, we can say elif x brackets I is equal to minus 100, x underscore f dot append minus 200. And then finally we can just simply say else x underscore f dot append 0.0, because we know that it's either going to be minus 100 or 100. If it's none of those, it's going to be 0. So that's how this is going to work. And exactly the same is going to apply to the y and z values. So we can copy all of this, paste it here, and then just say if y, yf, y, yf, yf. Come down here, paste again, z, zf, z, zf, zf. And that's it. That's all we need to do, because that will sort it all out. That will get all of this data and it will put the correct data in the correct places, and that's fine. That's exactly what we need. Now the final part of this is to simply say op, and I'm going to close this down, bring in this again, and then say is equal to false. So what's going to happen is that when this is clicked at 0, it will call this function, do all of this, and then set itself back to its off state, its unchecked state. And that's in case you forget to do it, because you don't want that left on, otherwise it will keep on playing around. Especially if you loop, it will reset every time you loop. We don't need to do that, so we'll put that in there as a failsafe. And that's the first function complete. So now we can code our animate function. So we'll take the word pass out of there and start work. We can start by saying if len trigger is equal to 1, duration is equal to frame minus start time 0. And as we've said so often, this zeroes things out along here. So if we get frame 35, we're going to subtract frame 35 from frame, which will be the same number and give us 0. We can then say if duration, and we'll say less than 30, so we'll do this over 30 frames or 1 second. And then we'll say for I in range len points. Because once again, we'll sequence through these. And now we can start programming our range mappers. So we can say x underscore range underscore mapper is equal to c4d dot range map brackets, and it will be duration comma, and it will be 0, 30 because that will be our input range. And then our output range will be x square brackets I comma xf square brackets I. We can then say comma false comma spline. We're using false in here as opposed to true because at times we're counting in the positive directions and at other times we're going to be counting in negative ones, so we must use false, otherwise this won't work. But that's all good. That's our first range mapper defined. We can then copy this and say y underscore range underscore mapper is equal to the rest, and this will be y, and this will also be y. Once again, we can paste again and change the x's for z's. And that completes our range mappers. They're all done, they're all ready to go. Moving on from here, we can say vect is equal to c4d dot vector brackets, and it will be, and I'm going to copy this from here, x range mapper, paste that in, paste it in again and again, and then change the x for a y and the x for a z. So that's our vector created. And then to finish off, we can simply say cube dot, and this time it will be set point, and it will be points square brackets I, comma, C4D dot vector brackets vect double close. And that completes this particular function. So a very simple function. All we're going to do is sequence through these points, feed them into the range mappers at the correct time, and then apply the data that we've got stored in these lists here, which we created up here. We're going to apply that data in sequence and use it to move our points. And that's it. That's really all we need to do. The only thing I can do just to finish these off, if we go just down here and put return there, and the same in here, we'll just put return and we'll put it here. It just tidies everything up. I mean, it's good practice to put return in. So we'll just do that to finish those off. Actually, I've made a deliberate mistake. Have you spotted it? What I've done, well, in fact, there's two deliberate mistakes. Point should be points. That's sorted that one out. But I should have also put else start time dot clear and trigger dot clear, just to make sure that once we've completed the current cycle, everything is reset, and then when we go down here we can see that start time and trigger will be less than 1, and we'll need to set them up again for when we call the function and start things over, because this will pulsate as long as the timeline is running. That's the key thing here. Okay, so we'll just take that back to there, and we're all set up. I think we can probably give this a go and see if we've got any syntax errors and other things in there, because it could well be, but we'll give that a go. But that is your code. That's as much code as you need to make this work. So it's, I suppose, a reasonably long expression, or well, it isn't really in real terms. It's only 111 lines, which is not really that much, is it? But it's a fair amount that you've got to code in there to get this to go, but only based around two very simple functions. One to set things up, and we only use that at the beginning of the timeline, and we only really need to do it every now and again, and then one just to make our range mappers and to move the points. That's the other one. That's just the animate just moves the points via range mappers and vectors and things like that. That's all it's doing. And yeah, that's it. That's really all there is to it. So let's give this a go. We'll see if anything works. So it's saying here I've got a syntax error in line 29, so let's just check line 29. So for I in range len points, and what have I got there? I've got one. Oh, I've got 3 opens. I need a double close, do I? I've got a double close. Then points. Actually, I don't need that open. It's just then points. I need that one there. That should be okay now. Let's have a go. Let's see what we've got. Let's run this. Right. Okay, we've got another one. We've got 69. So let's have a look. 69. Let's have a look. 969. So c4d.rangemap. Oh, of course, I should have put c4d.utils.rangemap. That's what I should have done there. Same here. Let's just get those in. See, these are deliberate mistakes I'm making. I'm just hoping you're spotting them. Okay, so let's see what we get now. There's probably still some more errors in it, but we'll see. Yep, what do we got? X is not defined. Let's have a look. Yeah, okay. The reason it's not working is because we haven't used the setup function. So what we need to do is go into our controls here, and we need to use the setup function. So let's do that. It's done the job. You saw it click on and then click off. So it's been through this because we're set at frame 0. So hopefully that set things up and it will work. And it does. And there you go. Okay. Right, so let's have a look. We're getting a little bit of an error when we're looping. Now I know why that is. If we go into the tag here, we've got reset on frame 0. This is a pain in the bum. Take that checkbox and uncheck it, because what happens there is once you loop back to 0, everything that we've set up here will be lost because it resets at 0. So definitely uncheck this box, and that should solve the problem. Let's just go back into our controls, go back into this. We'll go back to the start of the animation, click on setup, and let's see what happens now. Right, now we've got another problem, and that's happened because of what we've done with the loop there when it went through and didn't set up properly. Now what's happened here is that it's taken the cube at its last position, basically the state that it was in when we looped, and that's caused this problem. So what's happening here is that none of this is working now, and it's just seeing everything. It's saying if it's 100, well, it isn't 100 because it was something else. If it was minus 100, well, it wasn't, it was something else. So we're just left with the else. So it's setting everything up or zeroing out the points, and you can see what's happening, because if you look at it, the points, they're clearly going back to 0. They're going from 100 or minus 100 back to 0. So it's literally setting the XF, YF and ZF up with 0, 0, 0, 0, and that's why that's happening. So what you have to do in this situation is lose the cube, just get rid of it, and then bring another one in, and then we can select this again, set it up again. So look what we got here. It's just, we've got the cube in there, it's definitely there. Go into there. Why doesn't it like that? It should like it. I know why. I know why. The other thing you've got to do is this. You must set it up with the correct number of segments. So this is all worth showing you. These are the errors that are easy to make. So if we just hit that now, it sorts itself out, and that's now set up, and it should work, and it does. We can hide this other cube now because we don't really need to see it, and we can. Let's have a look at what's going on here. I'll tell you what we'll also do. We'll get rid of the Fong tag, because that's actually more trouble than it's worth. So that's looking quite good now. I think it gives you a better result, and you see more or less what's going on in a better way without the Fong tag on it. And of course it's not lit or anything. There's no lighting other than the basic light, the scene light that's there. But you can see that this is all working now, and it pulses away and it loops and everything's okay. And you can stop and you can go back to the beginning and it will all work. It just resets itself and it works. But yeah, the reason that's all working now is because we took this reset on frame 0 away. So yeah, that's your enemy in this case. And not always. I mean, there's different situations where you might need that, but for stuff like this, where you're going to create a setup like this and you don't want to do it again, then definitely switch this off, because it will be a pain in the bum if you loop. But yeah, that's all working really nicely. So that about completes this tutorial, and I hope you found it useful and that you've got some interesting stuff from it, and that you can actually do something with this in your own projects. I mean, I'm not absolutely sure that it's all that useful. I mean, I suppose what we've created here is technically a pose morph for a parametric object, because normally you do a pose morph on a geometric object, and this is effectively the same kind of thing. I mean, if you wanted to, you could do various different numbers in here. You could say if it equals 100, you know, so these could be say 300, or if it equals minus 100, they could be minus 50. You know, there's various things that you could do so that you could get different results if you wanted to. I mean, certainly you could adapt this further so that you could actually make the cube morph into something more complex. I mean, you could give it more fillets, or more segments I should say, and get more points in it and make a more sophisticated setup for it. I mean, at the moment we're only using 6 points, but you can use any number, you know, so you could make something a lot more sophisticated with this and make it morph into a completely different shape. You know, maybe you could make it morph into a house, I don't know. You know, there's various different ways that you could use this, but yeah, I mean, hopefully you know, Link, you've got something out of this if you're watching and you've found it useful to you, and that you might have some ideas for things to do with it. But and if you do, then please show me what you've done, because it's always interesting to see what people are doing with this stuff. But yeah, I mean, that for now, that does complete this tutorial. So I really hope you've enjoyed it, and if you have, then please give the video a thumbs up, and if you haven't already, please subscribe to the channel and leave a comment and ring the bell. And wherever you happen to be on social media, please share this video, because all that good stuff, it really does help the channel keep going in the right direction. But anyway, for now, that about wraps this one up, so I'll see you very shortly on the next tutorial.